The extreme value theorem is another theorem that tells us, in a way, that continuous functions are very nice. It will give us a way of knowing that a function has a maximum and a minimum in a quite simple way. So the extreme value theorem tells me that if I know that my function is continuous on a closed and bounded interval, so it has to be of the form closed a, closed at b, where a and b are both real numbers, so we cannot go all the way to infinity, then on that interval, f attains both a maximum value and a minimum value. And in the extreme value theorem, again, all the hypotheses are needed. You see, if we drop the boundedness, then the function f of x equals x cubed is continuous but has no maximum, because as x goes to infinity, x cubed also goes to infinity. If the interval is not closed, then the function f of x equals x squared is continuous, but it doesn't have a maximum on the open interval -1 to 1. X squared would get as close as it wants to 1, but it will never reach that supremum of the f of x in that interval. So that's why we need a closed interval in this case. And if the function is not continuous, then we again run into problems with, for example, the function f of x equals 1 over x. It doesn't have a maximum or a minimum because it has a vertical asymptote at 0. So it would just have a problem with that. So we don't have a maximum because when we get very, very close to 0, we're going to just escape to infinity. We cannot have a maximum. So this shows you that all the three hypotheses, that the interval is bounded, that the interval is closed, and that the function is continuous on the interval, are required. I invite you to draw some graphs of functions that violate one of these three conditions and show that indeed would not satisfy the conclusion of the extreme value theorem. Now, the intermediate value theorem, the one that we saw in the previous video, tells us that continuous functions take intervals and send them to intervals. And if we combine the intermediate value theorem and the extreme value theorem, we get that continuous functions send closed and bounded intervals to closed and bounded intervals, which is quite nice actually.